In the last segment, we wrapped up with electrolytes. And the reason that electrolytes are important in the body is that they're essential for nerve and muscle function. By the way, you may have heard my dog whining in the background, which is why I was a little all over the place in how I was talking to you. Nonetheless, this segment begins on page 15 in your lecture notes, and we'll talk about solubility. Now, we've talked about solubility in terms of the ability of a solute to dissolve in a solvent. And we've looked at this qualitatively. We've asked the question yes or no. And where did we go look to see if something was soluble? Well, if it was ionic, we went and looked at the solubility table. If it was soluble, we called that aqueous. If it was insoluble, we would say that that would form a precipitate if we had an aqueous plus an aqueous yielding something that was insoluble. We would call that a precipitate, which is a solid. If it was non-ionic, something like CH3OH or some sort of rendition of CH2O, we would have to determine yes, it's soluble or no, it's not soluble based on its polarity. And we would say yes or no according to like dissolves like. In your next course, you would go, here's yes, here's no. In the next course, there's this whole area in the middle, which is the well, sort of. Now, solubility, we're going to expand that definition to say that it's the grams of solute per 100 grams of water at a given temperature, which means that solubility is going to be a function of temperature. Now, saturated in this instance means that we can get the maximum amount of solute in the solvent at a given temperature. Unsaturated means we have less than max. Now, you can have supersaturated, in which you can squeeze more than max. And if you were in a more advanced chemistry class, you would actually use that to recrystallize a solid. Page 16. Here are some charts that may or may not be familiar to you. You can see on this chart that everything here is ionic. We have temperature versus solubility, and you can see the units, grams of salt. Salt just means something that's ionic per 100 grams of water. And you can see that for the most part, except for this cesium compound here, that most of the time as we increase temperature, we increase solubility as a general rule. You can see that some substances are very, very sensitive, like potassium nitrate, almost exponential. There are other substances like sodium chloride, which are practically flat. On this side, what you see is temperature versus gases, and you can see a slightly different unit, millimolar, okay? Nonetheless, for gases, as we increase temperature, we decrease solubility for gases, and we'll come back to that in just a moment. Ionic compounds increase solubility, gases generally decrease solubility. Okay, now what you're going to want to do is you're going to want to be able to quantitate solubility based on the values that you see in the table, okay? Now, the question here is how many grams of sodium nitrate would there be in 75.0 milliliters of water at 20 degrees Celsius? Well, what you need to recognize is that your unit is grams. How do you get from grams to milliliters? Well, to go from grams to milliliters, you need density. And the density of water, you either know or you go look up. And the density of water is generally regarded as 1.00 grams per milliliter to 3 significant figures for most room-like temperatures. So we're going to have 75.0 grams of water in our situation here. All right, so we're going to look on our chart here, and we're going to see that at 20 degrees, we're going to estimate our solubility of sodium nitrate at about 87 grams of sodium nitrate per 100 grams of water. At that temperature. Okay, now we're going to be a little bit relaxed with our significant figures because we're reading a graph. Okay, now we're going to set up a ratio, X grams NaNO3 per the 75 grams of water that we have available to us, and we're going to solve for X algebraically. Okay, when we solve for X algebraically, we're going to get 65 grams of NaNO3. Okay, now what that means is if we put 65 grams of NaNO3 in 75.0 grams of water, that will give us a saturated solution. So if we want something that's unsaturated, we would put in something less than this. Okay. Also, if we cooled this down, we would not be able to get this much solute into the system. And the sodium nitrate crystals would start to solidify out of solution, and you would end up with a solution that has crystals at the bottom. Okay? How many grams of KNO3, okay, so let's change this to KNO3, would there be in an unsaturated KNO3 solution at 40 degrees Celsius? All right, so we're going to look up KNO3 at 40 degrees Celsius, and that looks like that's about 62. Okay, so let's say that this is 62 grams of KNO3 per 100 grams of water is max at 40 degrees Celsius. Okay, so unsaturated is anything less than 62 grams at 40 degrees Celsius. Okay? In 100 grams of water. All right? Page 17. If sodium chloride has a solubility of 36.0 grams at 20 degrees Celsius. Okay, so solubility means 36.0 grams NaCl per 100 grams of water. Okay, so now we're going to go to three significant figures because we're not reading a graph, we're being told this. Okay, how many grams of water are needed to prepare a saturated solution containing 80 grams of sodium chloride? All right, so now we're going to set up our ratio, 80.0 grams of NaCl in the numerator, X grams of water in the denominator. We're going to solve algebraically for X, cross multiply. X, here I'll do the math, 36 equals 100 times 80, divide through by 36.0. X equals 222 grams of water. Okay?